Hey, friend. So let's just jump right into talking about the subtraction thinking pathway. Constance Camille, one of my favorite researchers in this space, used to say that subtraction is as unnatural as addition is natural. And she went on to say that children learn subtraction by knowing addition very, very well. So this thinking pathway leans into that idea. First off, we're going to compare. We're going to compare the two numbers in the subtraction fact. Then we're going to connect to what we already know about addition. And then we're going to plan and solve. So, as we talked about in the last session, the strategies for subtraction mirror those for addition. The words change a little bit, and doubles and near doubles don't get used as much. It's not quite as robust of a set of math facts as some of the others. So we have those grayed out here instead. But let's just take a look at how this might play out. So let's take a look first off at count back and count up. So when I look at these two numbers, 11 minus 2, and I compare, I can see they're pretty far apart, and 2 is a small number. So I can just think 11, 10, 9, and count back 2. Makes sense? I could also use, if I wanted to, I can use manipulative. So I just have those there as a reminder that we can still be using visual and physical tools. So 11 minus 2 is 9. Now, what if I had 11 minus 9? If I compare these, I can see that those two numbers they're pretty close together. So maybe in this case, I want to count up and think 9, 10, 11, since they're so close together, right? And I'm using counting up, I'm using what I know about addition to help me with subtraction. So 11 minus 9 leaves me with 2. So by comparing the two numbers in the fact and then leaning into what we already know about addition, that makes those facts more accessible for our students. And that's when you're subtracting 1, 2, or 3, or when the two numbers are only 1, 2, or 3 apart. Next, we have on make a 10. And this is, of course, the corresponding set of facts to make a 10. So here we have 10 minus 6, or 10 minus 4, or 10 minus 5, right? So what we want the students to do is if when I compare this, when I look at 10 minus 6 and I compare them, I can kind of lead right into connecting to addition. If I'm starting with 10, I know that I'm dealing with a number pair that makes 10. So 10 minus 6 is going to leave me with 4. 10 minus 4 is going to leave me with 6. 10 minus 5 leaves me with 5, which is also a double. I could have been thinking doubles there instead, right? So unmake a 10 again is just seeing that relationship between the numbers, the number pairs that add to 10. Then subtract a 10, kind of similar, but now we have a teen number and we're subtracting 10. So I'm going to compare those two numbers. I'm going to say, oh, I am taking out a 10. I know that 10 and 7 make 17. So I'm connecting to what I know about addition to make my plan. And the corresponding fact would be 17 minus 7. If I have 17 minus 7, I once again can still remember, oh yeah, 10 and 7 make 17. So I'm leaning into what I know about addition to help me with subtraction. And then the last of the foundation facts was the idea of doubles, right? So I would hope that my students, when they see 8 and 10, they compare 8 and 10, that they'll connect that to what they know about addition and remember that 8 plus 8 is 16, right? Or if I simply had 6 minus 3, recalling that, oh yeah, 3 and 3 makes 6. So just using what we know about addition to make that plan to use doubles. Now, the corresponding idea here would be instead of 16 minus 8, maybe we have 15 minus 8. So 16 minus 8 would have been 8, but I have one less, so 15 minus 8 is only 7. Now you can see that really seeing that relationship is probably not as obvious as some of the others. So that one gets used a little bit less. At the very least, I would love for my students to be able to lean into their doubles. but the near doubles just doesn't quite get used as often. Now, pretend to 10, that was when we used a 9 or 8 to help us to with a fact. For example, if I have 16 minus 9, I can temporarily think I know 16 minus 10 is 6, but I only had 9. So I have to add one more onto the 6 to be 7, right? So there again, that one's a little more confusing for our kids, but they can lean into what they know about addition to help them with their subtraction. So we're looking at those relationships and then connecting to addition. Now, unmake a teen to take from 10. This one is the most complex, but maybe one of the most useful ideas when it comes to the subtraction fact strategies. So let's unmake a teen. So let's just say I have the number 14 and I'm going to subtract 6, right? So what I'm going to do is I'm going to bridge temporarily. I think of this as a 10. And then I know 10 to 14 is 4. 10 to 6 is 4. 4 and 4 is 8. So 14 minus 6 is 8. So what I did is I unmade this 10. I know 6 and 4 is 10. And then 10 and 4 is 14. And then those are the numbers that go together to give me my total. What if I had 17 minus 8? I'm going to think about using 10 as a bridge. So I know 10, all right, 8 plus 2 is 10. 8 is 2 away from 10. And then 10 to 17 is 7. So then 7 and 2 gives me a total of 9. Play with that. That one is a really powerful strategy. It plays out nicely with the manipulatives. It plays out nicely as a mental math strategy. So play with that and see if that will make sense for you. So let's just review one more time that when we're working with subtraction facts, we want to use a thinking pathway that helps us use what we know about addition. So first we're going to compare the two numbers in the subtraction fact, connect to what we know about addition, and then plan and solve. And just a reminder, we want to be using all of the different ways to represent mathematical thinking. So encourage your kids to use physical tools, visual, symbolic, verbal, and contextual as you have them using this thinking pathway. Next, we're going to jump into multiplication. See you there.